Hello, everyone. I am from South Korea. Is anyone from South Korea here? The only Korean in the audience. All right. So at this point, I'm more concerned how many of you will sleep with me, and I'll promise I'll finish quick. So I think this is a great illustration of where I'm from. That's 1950 in Gangnam. That is heart of Seoul, which is the capital city. That is the same Gangnam from Gangnam Style. It's actually, so those of you who did not know, it's actually a place. That's 1953, this is 2015. And it is staggering how much change my parents' generation has experienced in the last 60, 70 years. So for Korean people, at least, the industry that you currently serve, construction, definitely, no doubt, has disrupted our lives. So I think the industry should have received a little more credit than what goes around nowadays, where our industry is considered as to be not so sexy to the upcoming university students, whereas architectures make less money than plumbers, and so hopefully that'll change. If you compare this to the 1950s in Sydney and New York, that sort of gives you a little more perspective on how much Korea has come. And I grew up in Canada, born in Korea. In high school economy book, it was actually they actually had a chapter called Miracle of Han River, and it discusses of the development in the recent years in Korea. So it evidently gave birth to some of the large firms like Samsung, and Hyundai. That is, this little piece of land here was actually a government city land that was out for bid a few years ago. We estimated that it would be about $3 to $4 billion. Hyundai actually bid $10 billion and they won. So you know what to do if you have a time machine, right? And if you're in Korea. It's still under construction, and the technology that I'm about to speak to you have been extremely well appreciated by the firms that I just spoke, as well as so the dynamics of Korea in the 1950 to 2015. The people who experienced the 50s still alive. So there's a huge dynamic in Korea, and that reflects my work in Korea as well. So I work with these firms, as well as there's a small project like this where we have an owner that was brave enough to say, you could publish everything about my house that is being designed in Revit. The owner is an interior designer. He will use Revit. And the contractor also uses Revit. And my team is trying to help out and assist and apply as many technologies as possible to this small house so that we can prove to the audience, to the industry, that BIM is not just for Samsung and Hyundai with billions of budget, but also for everyone. So a little bit about myself. I currently oversee these two products when I'm outside of Korea. Edgewise is a product that, these are both laser scanning related software solutions. Edgewise automatically models off a point cloud, and Verity automatically checks between your as designed and as built, which comes from the point cloud data. When I'm in Korea, I serve a role of localization director at a local AEC solutions firm, and I do love Excel and Power BI. Has anyone ever heard of RPA? All right, that's good. So RPA stands for Robotic Process Automation. It's a pretty fancy term. You will start to hear about a little more. It's a scary term because RPA is being adopted by financial industry that is removing thousands of jobs. So a lot of Fortune 500 companies are consulting that. But I want to show you another example of automation, which I have a huge passion for, where it's not that scary or intimidating. So I've had our engineers, either in CAD or Revit or whatever environment, repeatedly see that they're clicking a middle button to move things to the center of the screen to do any action, whether to create, to edit, or whatnot. And if you're trying to move things with your middle button, not middle finger, and it poses a lot of stress on your finger, carpal tunnel. So I've created this little script where you will automatically emulate moving wherever the mouse is to the center of the screen so that you don't have to hold down a button for a long time. Now, it's really, really nothing, right? It's so trivial. And as it is trivial, it only takes 6 lines of code. But some engineers like it. Some engineers don't mind. And so the automation can be really in your daily work life. It doesn't have to be super scary or intimidating. By the way, this language I used here is called AutoHotkey, and it's free. And it's very easy to learn. I also like to carry my daughter around. This is to prepare myself for one day for someone to buy me a mobile backpack scanner, which costs only about $250,000. So I'm ready for it. So if you would like to invest. So I'm here to talk to you about technology, right? But the technology, usually, we have a saying in Korea about liquor where you start drinking the liquor first, then liquor drinks liquor, and the liquor actually drinks you later on. So I think we have a similar with technology. Sometimes you are looking at technology, then the technology looks at itself, and technology consumes you if you don't pay attention. So I think a clear objective is very important when you're evaluating technology. And today for my talk, it would be great if you can look at how the technology helps clarity. But computer-aided clarity. There's a big difference. We're not going to automate so that you're not needed, but we're going to automate so that we focus on how computer can aid your workflow. This is also the technology that was introduced 2 years ago here at BIMMAP, briefly. And in Korea, I had the fortunate time to launch this 4 months after the official launch in the US, which for me, it is a fantastic result. We rarely get a technology that was launched in the US that comes to our country in less than 4 months. It was a big achievement for me. South Korea in 1950s, out of process, people, technology, and policy, which are the driving elements of change, we had nothing but people, right? We had no technology, no process, no policies. So we're very good at leveraging people. That's why we can get people to work overtime and on the weekends without paying them. It's changing, so it's not that bad now. These are CMs. So that's the largest CM company in South Korea, ENR 14th in the world. They're sort of the owner's rep. There's about 70 CM directors here. So we're basically speaking to about 50 job sites. Land and Housing Corporation saw the similar technology that I'm about to show you. These are the largest public owner in South Korea. At any given moment, they have about 300 active job sites. They open about 60 to 100 yearly. And it was in the news, self-hosted seminar, Railway Commission, Incheon City. So all of this in 1 week. So Koreans work hard, right? That was in last year, August. Now, I was very excited about this technology. And why? Because I get to look at a lot of technologies. My company pays me to go to conferences like this. This is AU 2017. And analyze all the technology trends. Pick the ones that we should focus on. Last year, I picked these 4. So that's the technology. These are important keywords to watch out for and the players. And we will evaluate and pick the ones that we need to partner and launch into South Korea. So that's content, reality capture, and the technology that I'm here for today, Verity, is among them, and also field workflow. IT in construction industry, I think, is a lot like adventure. There's so much undiscovered land, undiscovered opportunity that anyone could find, like the new golden land. We really need a good newcomers from the universities. I really hope our industry could appeal to the young generations as interesting and adventurous as this picture would show. But oftentimes we do feel alone, like the picture, it's a single kayak. It is also a ride because you get to experience all the cool technology, the R&D, but after what we've seen with yesterday's keynote with Andrew at Lengeruk, I think my playground or my ride better resembles by this picture than the one below. I'm half joking, I do get involved in cool projects as well, but because it's such a small ride, when a big boys like that try to work with us, it is a challenge and both struggle. And sometimes the big boys are also intimidating. I haven't worked with him yet. I hope so in a couple of years. But day to day, I still work with an industry where large part of what they do is 2D. They design in 2D, but they consume on paper. So what part of, like how do we understand this? Like why would you create something in digital, but consume it and use it on paper? My professional career did not start in this industry. I'm about 7 years right now in this, in construction. But initially, I really had a hard time understanding this. So I needed a model to understand what the problems of the industry is and how I can look at technology and others to help make it better. And the model that has served me quite well, and the model we're going to continue to use today throughout my talk to evaluate the technology that I'm about to show you, is comprised of 3 elements of our industry. It's nothing special: owner's intent, architecture's plan, and builder's execution. I think as an industry we understand much more about these 2 than the owner's intent, just simply because lack of participation coming from the owners to the industry event like this or at AU. But it's basically, the model is that the closer these elements are together, the better our industry will be. The farther away, the worse it is. And I give this example, an analogy called Africa tour analogy, to help illustrate how the owners are feeling about our industry. So imagine we started, I was going to say 300, but it's much smaller crowd, so let's cut that down to 100. Imagine we're all one family, and I want to take you guys to a tour of Africa for 3 years. So I go to a local Africa tour company, local planning company, and I asked them, I have the intention to take these group of families to Africa for 3 years. Can you plan for me? What's interesting is the planning tour company has never been to Africa, and they don't give you the plan that can be executed. You don't know that, but they're going to give you a plan that can be approved by the African countries to let you in. So you end up giving up $1 million to this tour company, and they give you a budget for 10 million. And we arrive in Africa, all of us together. And first day, you guys are all sitting in the hotel. I meet the local guide that's supposed to guide us throughout African tour. And he tells me, oh my God, crap. The plan you have can't be executed. You've got to make changes. And all of these changes we've got to make in Africa, in African language, which I have no idea about. I just have the money. I just had to finance. And you guys just have to, quit your job to come to Africa. What's worse is it ends up that this local guide, local tour company, is just a contractor arranging company that arranges contracts with local tribes who is actually going to take us around. And the tour ends, right? However, the owners in our industry will have to live with that building for hundreds of years. So if you can briefly picture yourself in my shoes and the frustration of someone who wants to spend money on a large scale project, which rarely happens to a lot of people, there's so much confusion and frustration. Now, this is probably a lot of owners feel, I think, after they have built a building. Now, my take in this, to be fair, looking at construction industry, is that we are low in productivity because our size of the problem is much bigger. So other industry, maybe the snowball that they have to push to change is about this size, but our industry is probably much bigger because number of people, number of duration of project, cost, materials, it's just a big, big project. And we also have to do it right once. We don't get second chance. And it's both art and science. So I met a very good contractor that told me he has no issue with prefabrication on offices and factories, but if he's building his own house, he wants the interior finish, everything all done by human being. So as you can see, construction industry is not just purely engineering. So as you can imagine, you would not want an art, appreciative art, to have a very high productivity. Now, it is also many type single production industry, which makes it even more difficult, where some, like manufacturing industry, work with single type, many production, small type, small production. But us, it's many types. No two buildings are ever alike because the apartments look the same, but the earth composition, weather, you're not going to get the same trades, temperature. These are all environments that makes it very, very difficult and adds to the size of our problem. However, because it's a big, big rock, once it starts to move, I'm hoping it'll be unstoppable. So once the disruption starts to happen, I hope a lot of the laggards will feel like the Indiana Jones here and and face that, it's very hard to escape. So if we zoom out from that graph in about 200 years, I believe AEC and MFG will look more like this, where you can't distinguish that it has increased productivity. I think this disruption is really at the brink of our time. And a key factor that I see is that practice makes perfect. Everyone knows that, but you guys can only practice building a building mentally. You can't go out there and create an actual fabrication or a mock-up of the entire building, because that would cost just as much, right? So going from mental simulation to virtual simulation on whether you call that digital technology or virtual design and construction or building information modeling, which I usually try to convince people that it's actually building information movement, just so that no one can tell me they've done it and it doesn't work. And if it's a movement, you can't say you've done it and it doesn't work. Now, to summarize, this is what's in my head. I imagine our industry fighting this monster, and the weapons that our industry, construction industry here has, is policy, process, people, and technology. These are the weapons that can be wielded, and I'm going to talk about a small fraction of this technology using scanner today. And the three-headed monster is high risk, low margin, fragmented, with a sting design change. Now, this monster is called the gap monster, as I've illustrated before with the elements. And the closer we can bring planning to the intent or planning towards execution, we can all benefit, because less of a gap there is, we're going to have more owners that wants to spend more money and build better buildings, and hopefully more buildings. And the more we come together, it's actually not just our industry. Whenever something comes together, we become, one, and it's a peaceful world too, right? So I wanted to throw in some philosophy there, being Asian in the room. So this is a technology talk, once again, about clarity, but computer-aided clarity. We've come a long way from 2016, from our presentation 2 years ago, because for the first about 9 to 10 months since 2016, we've did a beta project on this technology called Verity, and these are the types of the buildings that we've used it. There were 60 participating builders over about 90 projects that we all participated in. And applying this model to the technology, I think the technology that I'm introducing today is closing the gap between plan and execution incredibly well. And why is that important? Because if you don't close the gap between planning and execution, stuff like this happens, right? You can't, I don't know if you can actually blame the planning or blame the execution for this, but it's not good. But imagine if the execution guy planned it, this wouldn't happen, right? If it's just a small house and you planned it and you were going to execute it, I don't think this would have happened, especially if it was for your house. And this technology was utilized in this project, and it shows a great example of closing that gap. So this was a design, I guess, sort of a flaw, where structure drawing showed H-beam without a slope. So it's supposed to have a slope, but the execution happened without. Now, the company, GC, that was responsible for this project in this beta was DPR, and they found this 2 days before the concrete pour, costing them about $6,000 to $7,000 to fix. Now, they estimated that they would have found this when the equipment came in without this technology, because you can't check everything in our industry, right? Then it would have cost them anywhere from $60,000 to $70,000 to fix the issue. So this is a great example of this technology closing the gap between planning and execution and driving value, in this case, to the GC. And I also think this technology serves a very, very good purpose between execution and operation, where operation is basically the result of intent after the project. And you can see that from this image. This is in Navisworks, a central utility plant in a hospital, where they expected to build an extension of this. So they wanted accurate as-builts. So imagine you have the plan here and execution down here. If you had to measure the model and the as-built, which is represented by the point cloud laser scanning in this case, and if it was more than the tolerance that you've set, which is 50 millimeters that is in the specification by the owner, if you color it yellow, and if you color it green, if it falls within 50 millimeters, you'll get this. However, amount of work that is involved, if you had to do this manually, is staggering. This is why, before this technology, even you could capture the as-built condition using laser scanner, you could not verify against the model every single element. So if you did it manually or automatically, there's no doubt that this technology serves clarity. It offers a huge clarity to the owner and to the GC. But the truth is, this picture was never shared with the owner. Why? Because owners may misinterpret this image and go have another oh my God moment. Is it like all wrong? It's not wrong. We all know that. The owners may not. So the problem is very big too. For our industry, we estimate anywhere from 5 to 12% of construction projects cost is based on rework, schedule delay, and downstream clashes. This doesn't involve the cost of the errors in the operation maintenance phase, and it's about 450 billion. Now, if we could check everything, it would solve the problem. But with traditional methods like measuring tape or laser, it's only feasible to check anywhere from 5 to 10%. The only exception that I've come across was Japan, where they were checking actually about 30% of field install, but it's no longer feasible for Japan too, because no younger trades are coming in and wanting to learn. And scanners are really being democratized right now. And these two poses a possibility. So if you can verify 100% of installation, spending only the time it takes you to traditionally check 5 to 10%, And if you can get the computer to do this automatically, then, well, you could be happy. Which is not the case if you read the fine print down here. It's a model dressed up to look like a happy project manager. So our technology is based upon laser scanning, which falls into the reality capture category, where when we say laser scanning, this is what we hope for, you know. We're not there yet, but reality capture has come a far way. So yesterday's reality capture, today's technology, we've got much more variety, and we're going to look at two examples of what's coming up. And keep in mind, these technologies, like much of technologies you've seen in the last 2 days, was never meant for our industry. But it's up to us to decide how we will use it. This is what was introduced in 2018 Intel CES event, where if you have a device like, Intel came up with a device like this and captured the stadium like so, and you'll capture a 3D pixel that they're calling voxels. And if you capture it in this manner, you can mimic a camera work like this without having a CG specialist work on it. Now, the impact of this is incredible, especially for the movie industry. So that is the traditional single camera view of today's capturing method in the cinema industry. If you apply Intel's this new technology, you're able to create a scene sequences like this with extremely minimal CG effort or green background. If we had directors here, you know, if they saw this for the first time, I think their mind would be blown. The problem is, guys, imagine how much data size this would be. We're talking no longer terabyte now. It's probably terabyte per second. So unless we go cloud and we utilize 5G for extreme low latency, we're never going to be able to even fathom using a technology like this because of the data size. And the second is the technology that was built by NASA to actually capture light years away stars. If you search Google right now for gigapixel images, you can find images like this where you can zoom in forever and the resolution stays extremely crisp. Now, these are the technologies of tomorrow because it's tomorrow for our industry. The technology exists. But in reality, if you have your BIM model, for you to get a point cloud like this right now, the reality is a terrestrial scanner. Basically, a scanner that sits on top of a tripod is most widely used. So if you capture your existing condition and bring it into Navisworks as point cloud, if you run Verity, it will automatically do the manual work that we just described and highlight the elements that are installed, that are not installed, if they are installed within the tolerance or not within the tolerance. It can also automatically give you translations. And underlying algorithm at the so under the hood, you select. It's much like clash detection. You'll select a selection in Navisworks and you bring it in, and Verity will bring in each geometry and then load the point cloud around it. Only 250 millimeters, because if something is installed, we don't expect that something is going to be installed like 2 meters away. Then there's no limit to the algorithm. So we bring in 250 millimeters around that object. We create a copy of your design model and we fit it. This is very important because if you ever try to measure a model with point cloud has something called thickness. So as an engineer, you don't feel comfortable picking the point that's inner end or the outer end, and you also don't have the time to pick multiple points and average them out. And the computer will do that for you. And then you can look at translations and heat maps, and so how the actual as-built condition is. You can export this out to report to CSV or an HTML report like this so that you can share with the trades and subcontractors, making them much more feasible to update the Revit model with this information than without. There's also the option to push automatically all the models in Navisworks as designed to fit to the as-built condition so that you can now run clash detection, taking into account how the existing installations are different from the design. We published 2 studies, and you can read more about these online. One is a DPR case where you are able to analyze 500 steel members in a matter of 2 days. Another is BEC. This is for as-built, closing the gap between execution and operation, being able to deliver a very accurate as-built to the owners. Again, matter of 48 hours, they were able to analyze over 1,000 elements. So we've come a long way because it was initially developed as a construction verification tool. And what we find the users use it for in the last couple of years is that you can find mistakes early that drives value to the contractors. It increases prefabrication because before you could not trust the MEP rack that you're prefabbing off-site is going to fit once you go inside the actual construction site. You can track percentage of work complete and use that for paying, BIM coordination, quality management, transparency. But what is, in the essence, it's basically lets everyone to know that what you're doing is being watched and measured. We have to be careful with this because it can be an oh my God moment for trades because they can check everything now. However, with any disruption and innovation, which we saw from my home country in South Korea, we've got to be brave. And I'm sure our parents were very brave when they were faced with this disruption and innovation. And I think we could use more bravery in our industry when it comes to adapting technologies, trying new things, even under the fear that we cannot build it twice. And this is how I want to finish my talk because I think living in Korea, we've witnessed from this from a lot of our parents. So, thank you.